Hi Daphne, good morning. What are you doing? It seems you are having fun again.
Hi, Feza, good morning. I'm adding numbers one by one from 1 to 100.
It must take a lot of time. I wonder if there is a magical way to do it. Hey, Arif is coming. Let's ask him.
Hi, Arif. Good morning. I have a question. I want to add numbers from 1 to 100. Is there an easy way to do it?
Good morning, Dafne and Feza. Yes, Dafne, I will answer your question, and I can actually do more than that. Are you ready?
Yes, I am ready. Are you the Wiz?
Yes, I'm ready too. Let the magic begin.
Well, Feza, it's not going to be magic. We will just do mathematics. But the final result, or the things that I will show today, may be quite interesting. Okay? But it is not magic. We will just do mathematics. Okay, so let's start. I will define S1 as the sum of numbers starting from 1 all the way to n. And let's define another sum, which is S2, which will be the square of these numbers all the way to n square. Okay? And let's define S3. So 1 cubed plus 2 cubed plus 3 cubed plus n cubed. Okay, so let's start with this summation, S1. So we want to add numbers from 1 to n. Okay, that's great. There are two ways to do it. Let me show you one way. So 1 plus 2 plus 3 plus the first solution, n. S1 can be also written as, so I can start from n. So I can add from n to 1, but in the reversed order. So it will be n plus n minus 1 plus n minus 2 plus 1, right? So when I add side by side these two equations, I get 2s1 on the left hand side. On the right hand side, the first terms, if I add them up, this give me n plus 1 plus. If I add the second terms, n minus 1 plus 2 is also n plus 1. Oh, this is really interesting. So this will go all the way to the last term, n plus 1. So how many of these do I have here? I have n terms, right? So 2 times s1 is simply equal to n times n plus 1. Then s1 is going to be equal to n times n plus 1 over 2. That's it. So if you want to add numbers from 1 to 100, you just put 100 here. So 100 times 101 divided by 2 is your answer. Okay, so let me write it down here. So S1 is simply equal to n times n plus 1 over 2. Is there another way of finding it? So I'll show you the second method. And then we will continue using that method to solve for S2 and S3. Okay, let's move on. Well, I want to calculate this. This is a binomial expansion, right? So using the binomial theorem, what I can say is this is nothing but x squared minus 2x plus 1, right? So what is x squared minus x minus 1 squared? So x squared minus x1 minus 1 squared. So this is equal to, okay, 2x minus 1, right? 2x minus 1. So now I will put numbers. So if I set x is equal to 1, what do I get here? 2 times 1 minus 1 is equal to 1 square minus 0 square. Then I'll put x is equal to 2. So 2 times 2 minus 1 is equal to 2 square minus 1 square, right? Good. So I can continue like this, and I can put x is equal to n, right? So 2 times n minus 1 is also equal to n square minus n minus 1 square. Good. So if I add them side by side, all of these equations side by side, starting from here, of course. So I have a factor of 2, then I have 1 plus 2 plus all the way to n, so nothing but s1, right? Minus. I have minus 1, minus 1, minus 1, n times, right? So it's going to be minus n is equal to. So when I add this side here, as you see, 1 square cancels this 1 square, 2 square is going to cancel that 2 square, all the way to n minus 1 square. On the right, I will have n square minus 0, which is simply equal to n square. So 2 times s1 is equal to n square plus n, but this is equal to n times n plus 1, right? So s1 is simply equal to n times n plus 1 over 2, like we found earlier. Okay, this is great. So I'll use the same method to find s2. This is interesting. But this time, I'm increasing the power, right? I hope you all remember finding the binomial coefficients. So let's find x minus 1 cube. Okay? So for those who don't remember, so we use that tree, right? Pascal's triangle, actually. So 1 plus 1 gives me 2. So I put 1 here, 1 here. So this is 3, 3. I'm adding 1 and 2 here to get this entry. 2 and 1 to get this entry. So I added 1 and 1 to get this 2 here. So this is 1, 4, 6, 4, and 1. Okay? So I'm using this row to calculate a plus b to the power 0. This row is good for a plus b to the power 1. So this is a plus b to the power 2. So this is the cubic plus b to the third. And this is a plus b to the fourth. Okay, a and b are real numbers here. So x minus 1 cube. So for the cube, I have 1, 3, 3, and 1. Right? These are the coefficients. So x cube. So I'm lowering this power by 1 for the next term. So it's going to be x squared, 1 to the power 1, but it's a minus. I'm going to pick minus 3 because I have 3 here. And then the next one is plus 3x. Drop the power by 1, increase the power by 1 for 1. So minus 1 to the power 2 is just 1, plus 1, and then minus 1. Okay, this is good. So x minus 1 cube is simply equal to x cubed minus 3x squared plus 3x minus 1. Okay, I hope you all remember that. So I'll put this one over here, 3x squared minus 3x plus 1. So this will be equal to x cubed minus x minus 1 cube. This is great. So I'll use the same idea. I'm going to put x is equal to 1. So 3 times 1 square minus 3 times 1 plus 1. 1 cube minus 0 cube. So 3 times 2 square minus 3 times 2 plus 1 is equal to 2 cube minus 1 cube. So it goes on like that. For the n term, I have 3 times n square, or n square, minus 3 times n plus 1 is equal to n cube minus n minus 1 cube. Okay? So when I add them side by side, what do I get? So 3 times 1 square plus 2 square, all the way to n square, I have s2. Minus 3 times 1 plus 2 plus 3, all the way to n. So I have minus here, minus 3 times s1 plus n times 1 is equal to 1 cube, 1 cube, 2 cube, 2 cube, n minus 1, n minus 1. So I have n cube here. Well, this is great. So 3 times s2 is simply equal to then 3 times s1, okay, I put it on the other side, plus n cube minus n. This is great. So I can divide by 3, both sides. Okay, so this is n cube over 3. So what is s1? Simply n times n plus 1 over 2. Okay, so if I equate the denominators here, I'll have a factor of 3 here. This becomes 6. And then this is going to be multiplied by 2. And this is going to be 6 here. Okay, so S2 is going to be equal to, so we have a common denominator. So there is 3n times n plus 1 plus, I can put it on the n parentheses, so 2n, so this is n squared minus 1, but it is n minus 1 times n plus 1. Okay, so we will just move on here and see what we get in the end. So S2 becomes, so n plus 1, n plus 1, n here, n here. So I can simply write it as n times n plus 1 parentheses. Okay, so this one has 3 plus, okay, so this has 2n minus 2. So 2n minus 2 over 6. So S2 is equal to 2n plus 1. So n times n plus 1 times 2n plus 1 over 6. Is this clear?
Crystal.
Okay, that's great. Now we will move on to calculate this. Okay. Now we will calculate S3. So in order to do that, I'll find this expansion first. So x to the power 4, okay? So minus 4x cubed plus 4x squared. Since there's minus, these terms switch sign, right? Like we did before. So this is 6x squared, so 1464, right? And then you will have minus 4x. And then I'll have plus 1. Okay, is this clear? Now, the idea is the same. 4x cubed minus 6x squared plus 4x minus 1 is going to be equal to x to the 4 minus x minus 1 to the 4. Okay? So let's find the relation. So 4 times 1 cubed minus 6 times 1 squared plus 4 times 1 minus 1 is equal to 1 to the 4th minus 0 to the 4th. Okay? So same idea, 2 cubed minus 6 times 2 squared plus 4 times 2 minus 1, 2 to the 4 minus 1 to the 4. So for the n term, n cubed minus 6 n squared plus 4 times n minus 1 is equal to n to the 4th minus n minus 1 to the 4th. Great. So we will add them up. Okay. Similarly, they're all gone. This cancels that. So on the right, I have n to the 4th. Okay. Here, I have 4 times. The first term is 1 cubed plus 2 cubed, all the way into n cubed. So S3 minus 6 S2 plus 4 S1 minus n. Okay, this is great. So let's do some algebra. We will just do algebra right here. So 4S3 minus, so 6 times S2. 6 times S2 is n times n plus 1 times 2n plus 1. This is great. Plus 4 times S1. 4 times S1 is plus 2n n plus 1. That's great. So this is equal to n to the 4 plus n. Okay. This is great. So 4s3 is going to be equal to, so I have n to the 4 plus n. Okay. Then I'll have plus this term here, n times n plus 1, 2n plus 1, minus I have that term, so 2n n plus 1. This is great. So 4s3 is equal to, well, I have n plus 1 here, n plus 1 here, and n here. So I have n to the 4 plus n plus n times n plus 1 parentheses 2n plus 1 minus 2, right? Let's look at it again. Yes. So this is simply 2n minus 1. Is this good? Okay. Okay. So now we can expand it a little bit more. So n to the 4 plus n plus. So this gives me n squared plus n. So this is 2n minus 1. Great. So 4s3 is simply equal to, let me erase that, n to the 4 plus n plus. So I have 2n cubed, okay, minus n squared plus 2n squared minus n. Okay? So minus n plus n cancels. So minus n squared plus n, 2n squared gives me just plus n squared. Okay? So I can put everything n squared parentheses. So this gives me n squared, this is n squared, plus 2n plus 1. But what is n squared plus 2n plus 1? It is n plus 1 squared, right? Okay, so I can divide by 4. Okay, what is that? So this is n times n plus 1 over 2 altogether squared. Wow, what is that? So n times n plus 1 over 2. N times n plus 1 over 2. Interesting. So S3 is simply equal to S1 squared. This is quite interesting, right? So what does this tell me? This tells me that if I add the cube of these numbers all the way to n cubed, okay, this is nothing but equal to the square of the sum of all these numbers all the way to n. Okay, so I'll just put it here. This is a really interesting result. So what does this say? It says that 1 cube plus 2 cube plus 3 cube plus dot plus n cube is equal to 1 plus 2 plus 3 plus dot plus n all squared. And this is quite an interesting result. You see, Feza, I didn't do any magic here. I just used algebra to get this result. In the end, it turned out to be something quite interesting. But it is not magic. It's just mathematics, right? So I hope you enjoyed it. And thank you guys for all watching this video. I look forward to seeing you all soon in other videos. Take care. Have a fantastic day. Bye.